231. Next permutation. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. So let's go through an example. In this example, we have a list 1, 2, 3, and these are all the possible permutations of this list. 1, 2, 3, 1, 3, 2, 2, 1, 3, and so on. And what is the next permutation means, like as you see, if we consider this list as an integer, this is going to be 123, 132, 213, 231, and so on. So the next permutation of 1, 2, 3 is going to be 132. The next permutation of 231 is going to be 312. And as you see in these examples, it's showing that, for example, if we have 303 to 1, which is kind of 321, the next permutation is going to be the first permutation that we had in the list, because we consider it as a cycle. So let's go through an example, a more solid example. We are going to consider that we have a list 6, 3, 2, 1, 2, 5, and 4. What we are going to do, we are going to take 4 steps to get the next permutation. First thing first, we are going to traverse this list, right, from the end to find the first decreasing order. What is the first decreasing order? Let's start to traverse this list from the end. 4 is smaller than 5, so it's increasing order. 5 is bigger than 2, so this is decreasing order. So we consider this as the index that we were looking for. What is the index of 2? Is 0, 1, 2, 3. So index 3 is going to be the answer here. Then we are going to find the first largest element, not the just largest one, the first largest element by traversing the list from the end to index 3. So let's check that. Is 4 bigger than 2? Yes, it is. That's it. We are going to return that. 0, 1, 2, 3, 4, 5. Index 5 is the answer for the second step. Then we are going to swap the indices of 3 and 5. So after swapping 2 and 4, we are going to get this list as the result. And then we are going to reverse the list from index 3, from index 5 to 3 or 3 to 5, it doesn't matter, after 3. And then the answer is going to be it's going to be 6, 3, 1, and then we have 4 here, and 2 and 5 is going to be the answer. Let's implement what I've explained here and see if it works. Let's start from the first step, that we need to traverse the list. For traversing the list, we are going to consider length nums minus 1. We are going to traverse it from the end and see if we find the first decreasing order. It's going to be while I is bigger than 0 and nums I is smaller than or equal to nums I minus 1, the one beside it. We are going to minus 1, that because it means we have not found the first decreasing order. After finding that, what we are going to do, this was the first step. After finding this, what we are going to do, we are going to find the first largest element, and for doing that, we are going to say I is going to be minus 1 and j started from the end of the list, nums minus 1, and we are going to say if I is bigger than or equal to 0, because we don't know what has happened to the I from this step, and then we are going to decrease it 1, so we need to make sure that I is going to be positive and not out of range, and we're going to say while j is bigger than or equal to 0 and I is smaller than j and nums j is smaller than or equal nums I, what we are going to do, we are going to decrease j, because it means we have not found the first biggest element yet, right? And after finding that, we are going to swap that, we are going to swap I and j. Right? We are going to swap them. And after swapping them, we are going through the third step, which is, this was the third step, so sorry my bad. So we swap them, and the last step, which is reversing the list from index index I minus 1. So we are going to consider j and k, and we are going to say I plus 1, and length nums it's going to be -1. We are going to swap them around. We are going to say while j is smaller than k, nums j and nums k are going to be swapped. And then we are going to say j plus equal 1 and k minus equal 1. And there we go. And we're going to return nums. And let's run the code and see how it works. Okay, I have a typo here. And it seems I have another typo. There we go. So what we need to know about this is the time complexity is linear, because we are going to find the next permutation in one like traverse. And the other thing is the space complexity is constant, because we are not using any auxiliary space. Thank you.